Oh man, volumes of pyramids and cones and spheres. Oh my. Today we are going to be looking at, obviously, volumes of pyramids, cones, and spheres, and we're going to be looking at a few YouTube videos to help us figuring out formulas for each of those things. Will it be creepy? Yes. Will we have fun watching these? Probably not, but these are going to help us go ahead and figure out these volumes. So let us get started. So let's begin with pyramids. So pyramids, the definition in geometry is that you have a base, and then all of the corners of that base then converge at the top at a point. Now, obviously, a square base pyramid, like the ones over in Egypt, those are probably the most famous, but you can literally make a pyramid out of any geometric shape. For instance, you can have a triangle on the bottom, and then those corners kind of all converge up at the top apex. You could have a hexagon at the bottom with all the corners or the vertices converging up at the top of that as well. So literally any kind of flat geometric shape, you take the corners of those, that shape, converge it up at the top. It doesn't even have to be perfectly, like perpendicular with the base. It could be slanted too. These are all known as pyramids. So how do I find the volume of one of these guys? Let's go ahead and find out. Let's go on YouTube real quick and let's watch this creepy video. Here we go. Ooh, loving the music on this. Ooh, look at this. So we got a square base, looks like prism, and a square base pyramid. It looks like he is dumping. Ooh, there's another one. Dumping the pyramids into that original prism with the same height. Ooh, would you look at that? Don't spill anything, bud. Whoa! So it looks like 3 of those boys went into one of the prisms with the same height. So it looks like that pyramid was like, I don't know, 1/3 of that. So here we go. Looks like we have a triangular. Ooh, wow, fancy. Triangular prism here, stacked up next to a triangular pyramid, and let's see if the same effect happens with what happened last time. So here we go. Ooh, clear water this time. Let's go. So fill that in. Okay, it's about to be a third. Ooh, fancy schmancy. Okay, third time, and oh, wow. Amazing. So, I don't know about y'all, but it definitely nice, bud. It it definitely. Ooh, what's this? Let's get back into this. We'll come back to that in a second. Well, it looks like pyramids are, for the most part, going to be a third of their corresponding prism, if that makes any sense. So let's take a look at this. So for instance, if I have a rectangular prism, we find the volume of that by just getting the area of the base, in this case that rectangle, right? And then that would be how many cubes or squares are in one layer, and then we multiply it by the height, which is how many stacks, right? Well, if I have the exact same base here, I could just imagine this as being, that same kind of prism, but instead I just cut it in thirds, because that pyramid is going to be a third of the original prism's shape. So let me show you what I mean by that. If I have a same base, right, 3x4 square, right, and I have the same height. Now, pay close attention. The height of this would obviously be measured from the base all the way to the top, not like one of these slant heights. So be careful there. But I could find the volume of this and volume of this very similarly. For instance, I would find the volume of this right side by just taking the area of the base. 3 times 4 is 12 times 9. And there we go, 108 units cubed. I could similarly find the volume of this pyramid by doing the area of the base, 3 times 4, times the height, 9. But taking it one step further, dividing it by 3, I could then find out the volume of this pyramid. So 36 units cubed would be the volume of that. Likewise, I could take a triangular pyramid, In this case, we have like kind of like this right triangular base, right? And I have this vertical height of 4 millimeter, and they want me to find the volume of this. I could do that by taking, again, the area of the base times the height divided by 3. Well, the area of the base is, well, the base itself is a triangle, so what's the formula for a triangle again? What is that? Half the base times the height, right? So half the base is 3 times the height is 3, so half 3 times 3. That would be the area of the base, and then how would I find that? Well, the height would just be 4, so it would be half the area of the base, 3 times 3, that'd be 4.5, right? Times 4, which would be 18, and then you would divide that by 3, and that's how you would find the volume of this. And I thought I had that on there. I guess not. Let's go on to cones. Let's switch gears and let's watch this video. Ooh, much more upbeat. So let's talk about cones next. Ooh, same height, very cool. Got like magician vibes here. Let's see here. Ooh, fancy. We got a cylinder with the exact same base as this. Ooh, cone. Ooh, same exact circle. Let's go. Okay, ooh, blue liquid. A little terrifying, but okay. So we're gonna pour that into the cylinder next to it. Oh, thanks. This time he's got an expo marker to save the day. Let's go. I don't know about you guys, but that does not look like half to me. Maybe it's a quarter. Definitely not a quarter because it looks like we're over half now. So if you're probably in the guessing industry, this cone looks to be having the same exact kind of relationship as the pyramid did, because as you can tell, 3 of those cones filled in a cylinder. So chances are, guess what, y'all? Same relationship as before. So we have the area of the base for a cylinder with the exact same cross-section circle as this cone here to the left. The area of the base would be, again, the area of the circle formula. So 3 squared times pi times the height, because that is just how we find the volume of prisms. This one, same idea. We find as if we were looking for that same cylinder, except we just divide it by 3. So, in conclusion, pyramids and cones, the volume formula for them is the area of the base shape. So, for instance, cones, the base shape is circle. For pyramids, it could be a square, triangle, hexagon. It could be a lot of things. You find the area of that base, you multiply it by the height of the 3-dimensional shape, you divide it by 3. There we go. That's just the volume. So last but not least, we're on to spheres. Spheres, again, are just the 3-dimensional ball. So how do we find the volume of spheres? Well, back to this very up-tempo magician. Let's go with this. Here we go. So he has his cylinder, it looks like, which has 3 cones kind of piled in there. He's very proud of this, by the way, which is why he stood. He's very strong. He's been lifting weights. He can actually hold on to it. He's going to dump that back into the pitcher of water. And he's going to fill up a sphere. Now, this sphere, to be honest, let me just pause this for a moment. We already know, like with his magician hands, that they're all the same height, right? You should also note, because he didn't really do a nice job with waving his hands, that this cross-section circle, so for instance, in the middle of that sphere, that circle, if you were to just slice a 2-dimensional shape there, the circle there at the base of that cone, and then the circle of the cylinder, they're all the same circle. They all have the same radius. They're all pretty much the same flat circle. So I just want to make that clear. That's why these all match up. But anyway, let's continue with this dreadful pouring job. Looks like he's spilling a lot, but here we go. Ooh, filled up the sphere, and now he's dumping it into the cylinder. Okay, we got a third of the way there. Okay, cool. Gross. And we're done. Holy crap. It's a miracle. he's filled in 2/3 of that cylinder with just one sphere. Holy moly! That's like 2 of those cones. Oh my goodness! It's like a sphere and a cone equal 1 cylinder. This is amazing. Eureka! Okay, all right, it's not that exciting. So anyway, let's talk about spheres and let's talk about a formula for them. So as we saw in that super awesome video, that really it looks like a sphere itself, its volume is 2/3 of the volume of a cylinder with the same height, same radius, side by side next to each other. So we do know how to find the volume of a cylinder. We talked about it last time. It's the area again of the base times the height. This is the exact same thing we do for all prisms. So it could be just written like that. But let's talk about how we could write maybe a formula for the sphere, okay? So we could just say, well, the volume of a sphere would be 2/3 of that formula, because that's what we saw in the video. But let's be a little bit more specific. H's, the height, they aren't usually given to you when information of a sphere is given. So what typically we can do to simplify this formula to make it a little bit nicer is this height, which happens to be the same height as this, goes through the middle of this sphere. And the definition of a radius is the distance from the middle of a circle, or in this case a sphere, to the outside corner. So technically this height is really how many radiuses? And if you guessed 2, you are absolutely correct. So another way you could write this volume formula for a sphere would be 2/3 times pi r squared times, instead of h, 2r, because there are 2 radiuses. Now, I can simplify this just a little bit more. So for instance, I could reorder this multiplication, so I could take this 2 and multiply it with the 2/3, and I could have this r multiplied with the r squared. So for instance, think 2/3 times 2, well, 2 over 1, multiplying straight across, you'd get 4 over 3 times 1, so 4/3. And then an r squared times an additional r would be r, well, times r, which is r cubed. Nice. So that could be just written like that. So you'll see this online if you Google, like, what is the formula for the volume of a sphere? It's just 4/3 times pi r cubed. And you might be like, well, where did they get that? Well, exactly where we got it from the film, is that spheres are 2/3 of a cylinder. So if we know how to do the cylinder and we multiply by 2/3, as the same as finding the sphere. So hopefully that helped you out with cones, with pyramids, and spheres. Today's assignment is just a bunch of volumes with those shapes. So best of luck with that. If you have any questions, office hours again are daily, Monday through Thursday, 1 to 2 p.m. If you don't have any further questions, you guys have a wonderful day. Bye.